So, getting back to this whole efficient frontier thing. So here's the gist of everything we kind of talked about. Combinations of the risk-free asset and the tangent portfolio provide the best risk and return trade-off available to an investor. So these are kind of like the things the terms you have to know. All right. This means that the tangent portfolio is efficient and that all efficient portfolios are combinations of the risk-free anything like treasury securities. Risk-free investments are like treasury securities and the tangent portfolio. Every investor should invest in the tangent portfolio independent of his or her own taste of risk. Anyway, I don't do that kind of stuff. I don't know anybody who's ever done that. But again, this is underlying theory of portfolio theory, Markowitz's portfolio theory. Okay, so it all comes down to people's preferences as the tangent portfolio. Anyway, all right, so I want to shoot ahead to beta here. All right, so I'm going to jump ahead here a little bit, all right? I want to talk about beta and your required return. We're going to talk about ultimately the capital asset pricing model. So let me go ahead. All right, so beta, all right, so everyone listen, beta, every stock in the economy has a beta, and it tells you about the volatility of that stock, all right? And beta and required return are tied at the hip, okay? So based on beta was going to tell you what required return you need, okay, based on non-diversifiable risk, okay? So it's all based on non-diversifiable risk. So again, don't worry about this equation. It's the standard deviation, the volatility times the correlation of the portfolio of each stock in the portfolio, right? Divided by the standard deviation of the portfolio. So it's the standard deviation of the individual stock times the correlation of the individual stock in the portfolio. All right, divided by the standard deviation of the required return on the portfolio, and this is correlation RIRP. Okay, so basically this is the variance, right? Standard deviation of RI divided by the standard deviation of the portfolio gives you basically is 1 over the variance, all right? And you could find that. So we're looking at the beta of a portfolio. Normally every stock has a beta, but now we're addressing the beta of a portfolio. Okay, so suffice it to say that beta just gives you, okay, so here is the final equation we have to know. And this is the only thing we're going to drive at. So I want to highlight this. This is all beta. Okay. So this is called the capital asset pricing model equation. And this equation you should know, and it's easy. You just take the risk-free rate, given the risk-free rate and the beta, and the expected return of the portfolio return. This should give you the individual return on a particular stock, okay? Or on a particular portfolio. So you can, I mean, again, don't worry about the math here, okay? It's it gets complicated here. So again, here's the expected return of a security. Okay, it's the risk-free rate plus a beta. So the important point that they're trying to make here, all right, is and you know, I just want to make a point here, all right. A portfolio is efficient if and only if the expected return of every available security equals its required return. All right, so here's the capital asset pricing model, and this is kind of really what you got to worry about. So there's a thing called the optimum, the capital asset pricing model, or the security market line, or capital market line. So when the tangent line goes through the market portfolio, it's called the capital market line. So again, you'll see the form of the capital asset pricing model. So here's the capital asset model. So here's volatility versus expected return. Oops, sorry about that. So this is the most efficient portfolio. Again, here's the tangent line, right? So here's the efficient frontier of all risky securities. If you look at this, this provides of all these the minimum volatility here with an expected return. If you want more, basically return, you have to take on more volatility. So this is the most efficient point, coming off of the risk-free rate. All right. So here's the very definition of beta. And I think we saw this a little while ago, right? So you don't have to calculate betas. Betas are always given to you, right? Betas are always given to you. So here's the expected return based on beta. And in this case, the beta happens to be 0.69. All right, so betas can be negative, by the way. They can go opposite the market. If the S&P goes up and that stock goes down, that beta will tend to be negative. All right, so in addition to the capital market line, there's a security market line. All right, so again, it's just a line on a graph. So here's the market portfolio. This is the capital market line here, right? And this is the security market line here. So Notice this is the security market line is beta versus the expected return, and the capital market line is basically volatility versus expected return. So one is plotting volatility versus expected return for the capital market line, and basically for the security market line here, it's basically beta versus expected return. Again, here's the security market line, all right? So here is beta. Here's the security market line, okay? And here's expected return. So there's a difference between the capital market line and the security market line, all right? There's a beta of a portfolio also. Irregardless of the math, all it is the sum of each percentage in the portfolio times the individual betas of the stock. So with all this math that you're being shown here, with all this math, all you kind of really have to worry about is nothing. All you got to know is you add up each beta times its percentage in the in your portfolio. All right, I think I tortured you enough with this chapter, so I'm